Hello, welcome back to Vectorization Live Noding. In this episode, I'm gonna explain to you like the breakdown of this setup. This is actually like an extension of the previous live noding. Basically, we have a single clock, and we have everything working, and the clock is being controlled by the frame. And in this case, this is actually an improved version. I turned the clock into a monad, so this is the clock monad. Oops, clock. And inside it is actually the setup that we have in the previous live noding. So yeah, by using the monad, kind of grouping the whole thing into a single node, we can easily turn it into this kind of setup, and we can, we can make any kind of interesting design. Yes, so it's become very like I don't know, each one of these become like a single entity, kind of like if you think about it like a modular origami, like this become like a modular setup, and you can continue designing based on this single clock, and then you can design whatever. So I'll take you to the process of creating this. So go back to clock number 5. We have this thing already working, and already I tidy up and mesh join everything, and we have skin measure as output. So yeah, it should work pretty easily. There is this thing like the multiplier and the offset stuff. Actually, you can also output that, but I'm not gonna do it. I'm just gonna make everything being controlled by this time. So I'm selecting this, and the next thing I'll do is to group it. Make group. So now we have the monad things already working. Go out, and we have this clock. We need to turn on the vectorize and split at some point if we want to give it like some kind of offset values. So we have the skin measure, okay, and we have the matrix here. If we use I'll save this first. If I use matrix in and apply a plane MK3, then this one will give it like a 4x4. Okay, so that seems to be working. It's just like a duplication, like a clone of the one clock. So we don't want the same clock. Maybe we want to randomize it. So I'll give it some offset, range, float, give some offset. We have 4 clocks, so we're gonna have 4 different float value. Okay, that doesn't work. We need to turn on vectorize and split. And there you go. That's our 4 different clock. Each one of them is slightly different because the time is being offset by this range float. We can of course randomize this further, or maybe even use maybe even using like a noise. So I will be interested to see what it looks like with noise actually. So noise, vector noise, plug in our array of value from plane. Let's make it 4x4. And the output scalar can go into this guy and offset our clock based on the noise. The offset is probably very small value, so we want to maybe multiply it by 60 maybe, and run it. So probably not the most interesting yet. Maybe if we use vector math here and multiply scalar 0.2. I know that this will, if we actually start to increase the number, maybe make it like 20 by 5, we have 100 clocks. This will start to give us like some kind of pattern. 20 by 5, 100. This one should give like 100. You see, everything works kind of correctly. I don't know, maybe the clock is already having like some kind of noise pattern. I don't know yet. But anyway, that's the whole process really. You can bake the clock so it's kind of working in real time. Other than that, that's the whole thing. This is like a clock monad, so this is clock monad, and with a monad you can do furthermore. So you don't need to go here and then make complex thing. You kind of encapsulate all this into this, and yeah, everything just works. With this guy, you know, actually you can properly name it time. So sometimes if the variable name is the same, it will kind of giving an error. But yeah, but there you go. That's a clock, and clock being vectorized and turned into a monad group in Sverchok. Hopefully you like this one. Let me know if you have any question, feedbacks. Thanks again for tuning in. I'll see you in the next video.